Okay, let's do some problems in this quiz 1 for confidence intervals. That way no one has an excuse but to get this done. Here we go. So on this one, we're told that Young wants to build a one sample Z interval with 82% confidence. Now this is not a normal percentage that you will see on an AP Stats exam, but it's a good problem nonetheless. Normally it's, we stick with the common ones, 90, 95, 99%, but sometimes they get a little tricky like this. So the thing we have to understand is if we look at a normal curve, here would be our point estimate as we call it. And if we want to be 82% confident, that means I'm going to go 41% each way basically. And that would probably be somewhere about right there to about right there. So this middle here that I just darkened in black is my 82%. If we do our math, 100 minus 82 means 18% missing total. Divided by 2 means 9% here, 0.09 there, and 0.09 there. Now, the reason why this is important is because if they give you an odd, unusual, in this case 82% versus the typical 90 or 95, 99%, we can't just look at the bottom of the t-table. We're actually going to go to table A. That's our Z table. And basically the way we'll do is we'll focus on the top limit here. If I'm missing 9%, that means this mark is at the 91% level, right? In other words, the middle 82% goes from the 9% mark up to 91%. If you do the difference, of course, there's your 82% in the middle. But anyways, we're going to look up 0.91 as close as we can. So if you look right in here, you can see that's 0.9082, 0.9099 is by far the closest to 0.91. Notice here, I'm now going past 0.91. So if we look up here, we could see our values 0.04. If we look to the side, 1.3. If you put those two values together, 1.3 with a 0.04, you can see you get 1.34. So therefore, long story short, our Z-star value would be 1.341 standard deviations left and right of our center point estimate. Now, another thing I'd like you to be aware of, though, is if you didn't like looking at a table, because I really haven't taught you much about reading a table A per se, on the calculator, we could take that 9%, because remember, on the left, there's 9% missing on each tail, right? And if you go to inverse norm on the calculator, how do we get here? We'll do second vars, then vars, and then we will select inverse norm in there. And once we select inverse norm, we'll put in our 0.09. We'll leave mu and standard deviation at 0 and 1 respectively. In other words, that guarantees we're doing a standardized curve, which is the table A. And some of you don't have this option, but leave it on left, because basically what it's going to do, if you look at a sketch real quick, is we're looking right here again, where this right here that's missing is 0.09, and we want everything left of that point to be our 9%. And if you press enter, you'll get negative 1.34. Now, why is it negative? Because we are left of the mean. Okay, that's the only reason, the meaning of that negative anyways. So long story short, either way, that's how you can get 1.34. Okay, let's pick the pace up here a little bit. Here's the second question I got. We were told that we were given a simple random sample of 40. Again, I haven't reminded you of this much, but when they say SRS, that's short for simple random sample. In other words, the sample was done randomly, right? And our sample size is a nice size 40. Our problem is only 6 of the responses did not use the overhead in the plane. Okay, so that means, well, let's just go through. Remember, we always test for randomness, independence, normality. Now, we already passed the randomness condition. Why? It was stated in the problem. What about independence? That passes because if I take 10 times 40, that's 400. And note, they already told us we have 1,000 passengers daily. 400 is definitely less than 10% of our population, right? We're sampling less than 10% of the population. So is the data a random sample? Yes, we would select that. Is individual operations considered independent? Yes, we'll select that. But here is where it fails on the NP test, as I like to call it, because if I took 6 out of 40 and times that with 40, right? This is our p-value. I would get 6, which is less than 10. Remember, we want the NP and n times 1 minus p to be greater than or equal to 10. So long story short, it fails here. So this one would fail with normality. It's too skewed, as we say, our results. Okay? And the only way to compensate for is we'd have to pick even a larger sample size. Well, technically we would want to pick a large, which would hopefully drive this total value up higher. But anyways, I'm getting into the weeds there. So that's 2 problems done, guys. Let's look at this one. Now this one, notice they want a 95% confidence interval. And to save time, we know, or you would look it up in a t-table, and Z star for 95% would be 1.96. We've done it numerous times in the class and in the videos. So you already know you're either picking this one or this one. And this is the logical choice. Why? Because if I have 12 out of 200, that's 0.06 for my p hat. So that's our point estimate. There's our Z star. And if you look right there, there's my P1 minus P over N square root. So the correct answer you would pick is C. All right, let's move on to the next one. All right, we'll make this our last one. So we have a large shipping company that wants to order within a certain delivery window. The key thing is we want to be accurate within 2 percentage points. That is our margin of error. So remember, margin of error always equals our Z star times our standard deviation. Technically, this should be S for standard error. But anyways, we are told that it's 0.02. And that will equal, now they want to be 95% confident. We just talked about that being 1.96. We could see that again at the bottom of our t-table, right? And what is our standard deviation? Well, guys, they told us this time that to assume that our p hat is 0.9 or 90%. So we're going to put in 0.9. We're going to times that by 0.1 because this is 1 minus 0.9, 1 minus the p, divided by our mysterious sample size. So now it's just a matter of grabbing our calculator and solving for n here. And we've done it numerous times. So let me just walk you through with the calculator. First, we're going to divide both sides by 1.96. So here you can see I'm dividing by 1.96, so we get 0.01. Well, that 0.01 equals the square root. We might as well times that together, so that's 0.09 over n. How do we get rid of the square root? We're going to square both sides. So we square our value, we get this scientific number. And as we talked about in class, right, once the square root is gone, since we could do this, right, and do cross multiplying, and we end up doing the 0.09 dividing by this scientific answer. And here, of course, we would round this up to 865. And that's why we would choose C. Okay, I'm going to take a look at one more I got and see if I can't squeeze it in. Okay, guys, how about this one? All they want us to do is set up a 90% confidence interval. We are told that 96 out of 200 use a landline. So what is 96 out of 200? That's 0.48. So we already know we're picking A or B because our point estimate has to be 48% or 0.48. How do we figure out this or this? Well, remember, this is our margin of error. For 90%, we should remember it's 1.645 times the square root of our P times our 1 minus P divided by, so that's 0.48 times 0.52, and our sample size was 200. Here is my calculator work. 0.48 times 0.52, we take that, we divide by 200, we take the square root, we get this, and we times by, this came from 90% confidence, right, our Z star, and so there's your 0.058. So again, what I did was I took this, I times it with the square root of that, times that, divided by that. And again, there's my calculator work. And so our margin of error came out to be, as you can see right here, 0.058 or 5.8% roughly. So this is how we would complete our confidence interval. Make note, we normally would take 0.48 plus the 0.058. We would take the 0.48 minus 0.058. And that would give us our interval. Okay, so guys, hopefully I was clear enough to you. I think this video is still very good and effective. Hopefully you agree with that. The point is, guys, this video I hope you take notes on. You watch maybe at least a couple times, multiple times. You have no excuse now but to at least get a decent score on quiz number 1 here. And let's get it done, guys. Grades are coming out by the weekend. You have no excuse because I'm setting you up. See you in class.